Hello, my name is Jeff Rush, and this talk is a demonstration walkthrough of the IPython interactive shell. Divided into 5 parts, this final talk in the series will cover session input filtering using an example of physics units for value representation, and show support for data visualization using the matplotlib. Let's get started. One of the things it can do is input filtering. I won't go into detail how to create those yourself. That's a little bit magic. It is documented, but this is what I mean. Let's write a domain-specific language. So first of all, let's exit IPython. Get all the way out here. Okay, we're back at our shell. Clear the screen. Back at the shell. So we run IPython, and we pass it another option, -p for profile. We're going to load the physics profile. Now this adds extra input filtering to what we type. I can type physics. Okay. Brings it up. Not much different. A few things have been defined at the top, but we're inside there. Now, suppose you had a mass, and it was 200 pounds. Notice we'll add units here. And the velocity, it's traveling at 30 miles per hour. Now, you've never seen Python code that lets you put units straight into your source like this. But the input filtering system lets you do that. So we have a mass, we have a velocity, and we can compute the kinetic energy using an equation that's perhaps familiar. Half mv squared. So we compute it, we type the energy, we get an answer, but we also get correct units with the output. Of course, pounds and miles, not very metric. So E is stored in pounds and miles. Let's convert that to unit, hit tab complete to find out what that is. And we'll convert it to joules. Now, I know that joules is a capital J, standard notation, so we hit return, nothing displays. It doesn't convert it and print it, it converts it internally. So E is now measured in joules. So E, what are you? Oh yeah, 8,000 joules. That's what happened when this the kinetic energy that it had moving at that velocity. Anyway, that's units. Now, the other thing is we're always playing with text here, and IPython actually plays well with graphical frameworks. It has another profile, another option, Pylab. Takes a little bit longer because it loads in some scientific options here. It hooks us into a matplotlib-based Python environment. Has its own little, you get more help about that. Now, briefly, they need a whole talk on matplotlib, but we go back to our Python's our browser. Let's go to the matplotlib site. Okay, so these are screenshots. It shows you the diagram and it shows you the source that generated this. Okay, well, yeah, this graph looks nice. So let's just go over here and grab this source right here. You'll notice it's not a lot of source, but I'm not going to explain all the code right now. That's another talk. And go back into IPython, and we type that cpaste command, and we paste that code. And there we go. We actually get to see that graph there. And I will close the window. And got lots of variables here now, so let's just clear out the variables here. And let's just do one other just for fun. What would be interesting? The bar chart demo. So we pop over there, we grab all this source, get out of the way, paste it in, poof, and we have our bar charts. And we have the source here to actually play with it. And we have the history. Anyway, that's the data visualization. As you see, it plays well with the graphics. It also hooks into WX Windows, and there's a variety of others it hooks into. That's it for this last part of the 5-part series. To download the IPython software, visit the SciPy URL. You can send comments to me at this address. I hope you've enjoyed this series. Thank you.